we are back, and we know already how the neuroevolution works in a high level, and you look at the code as well, and how to handle all the steps on the neuroevolution. And now we're going to learn a little bit about the library itself, right? And learn how you can apply this library and this, let's say, neuroevolution technique to train your model to play your desired game or to perform whatever you need, right? And in order to use this library, it's very simple, right? So first I present here the class that you have in the project. Very simple. You have the neural network that you already saw. It's just a simple class that performs feed forward, and you have the genetic evolution itself. It's the class that kind of handle all the whole evolution algorithm steps. And we need the population handler and the population item, right? And when you have those, it's very simple. You just create a list with to represent the population, and you pass that to a population handler, and then you just pass this population handler into our genetic evolution. And then to each interaction of your game, you need to program how when the game finish and start a new, let's say, interaction or generation, and just call evolve, and that's it. And what is the population item and what is the population handler? So that's basically the two things that you need to implement, right? So it's those classes cannot just use what you are providing. You need to extend those classes and implement the method that the classes has. And as an example, let's look at those in our project. And let's start with the car. Car, it is extending population item. And let's see what the population item has. Has the genome, which is a simple class that wrap our neural network, and has use genes method, which is the method that would be called to predict the expected output. In our case, to steer the car to the left or to the right, right? And you have some helpful methods here to kind of save the weights that we already trained it to not have to train everything again. But it's basically yes, and the genome is responsible to the mutation, to the crossover, and yeah, basically those three methods. So that's the population, has genome and has fitness. And fitness, it is to identify how was the performance of the given item in the population. And it's very simple. So you have here a calculation, simple of fitness, but you need to implement that based on your game itself. So if you take car, the fitness, it is basically the total car that it was take over. And if you take another example here to the bird, for example, the fitness, it is based on the score. And how was calculate the score? It is just calculate score. Yeah, and the score, you have to see how the score was calculated, which is just plus. You have, okay, I'm skipping a step. This is basically the item, right? So the next one that it's important we have said that we need to implement as well, it is the population handler. And this is where things also happen. And it'd be more interesting to look before we go to the other one. So population, you have car population, birds population, and smart cat population. Let's start with the car. So what's the first, let's go back and see what it is we have on this class. It is basically expect the population that implements population item, right? And we just start everything, reset. We may need that or not, depends on your game. And then one important method that need to be implemented, it is the calculation fitness, right? Which will basically calculate the fitness for your game. And also you need to sort fitness. Sometimes you need, sometimes you don't need, so just use this one here. It will depend. Like the calculation fitness, for example, for birds, it is like this. We take all the birds, do a sum, and then we do a score divided by the sum. So that's how we calculate our fitness, right? Let's take how we calculate the fitness for this was the bird, the caps, it is basically depend on the reward that we will calculate somewhere else, and we just square, not square, square 4, I don't know how to pronounce that, but this is to potentialize more the cars that a good reward, you know. Sometimes most are the same, so doing that to potentialize more. But yeah, that's the piece that you need to kind of come up with. It is how to calculate the fitness and how to give the inputs as well. And the inputs, how it is the input, it is where we see the inputs. Let's take car. The inputs of the car, it is when we define the steer. Yeah, the steer, and then when you're trying to get the direction, we have here our genome, and you have this method, use genes, and you pass the input to our genes, right? And then that's basically the model will give the output, and the output it will be forward, left, or so on and so forth. And if we take the bird, let's see, to find this, you just go to genome, yeah, and see here. Genome, it is called from the think, and we just pass the input, and the input, it is basically it's the pipe, the distance from the pipe. So you get the closest pipe, and that we convert that into so depend of the height, basically do some calculation where is the pipe exactly, and we give the input to our gens, and then we just use the output to define if it is up, like, you know, jump, the board will jump, or just do nothing. And that's basically that. So it is those three steps basically. So you need to implement the two classes that will be your agent basically, and then you need to just call the gens from your genome. When you already extend the population item, you're gonna have this method, this property, and you can call this method to give you the answer, what to do on your game. Very simple, and that's very powerful, and you can very extendable, and you can apply that to any game, and that is written in JavaScript, or you can interface with JavaScript. Okay, so yeah, thank you very much, and see you on the next lecture.